Okay, in this video is continuation from the part 1, product to sum and sum to product. So let's look at to the example 4. Given that these two equations, cos x plus y, cos x minus y equivalent to cos 95, this one is equivalent to cos 45, then we need to find out the angle x and y. So this is what we have to do in this part. We have to apply sum and difference formula that we have learned in 1.2, and then apply that sum and difference formula for both. So we will get cos x, cos y minus sin x, sin y equivalent to cos 95. So this is the first equation. For the second equation, for the cos x minus y, so we will have cos x, cos y, then plus with the sin x, sin y, and it is equivalent to cos 45 degree. And this is the second equation. So in order to solve for the x and y, we have to make sure one of the term can be eliminated. So between these two equations, so let me plus between equation 2 and also equation 1. Okay, so by add up between that two equation, we will get 2 cos x, cos y, and then for these two term, cos x, sin x, sin y, and then plus and minus, so meaning that minus with this term, so we'll get 0, and then on the right hand side equivalent to cos 45 plus cos 95 degree. And then for this one, we have to apply sum to product formula, cos plus cos. So we will get here 2 cos 70 times with the cos negative 25. So I just simply add up between two angle, divide by 2, and then the second one minus and then divided by 2. That's why we get negative angle here. So apply even odd properties for the cos negative 25 degree. So even odd properties for the cos negative theta equivalent to cos theta, and then proceed with the 2 cos 70 and then positive cos 25. So we can compare in order to get the angle x and y. So if we compare, so angle x is equivalent to 70 and angle y is equivalent to 25. So you should conclude your solution. So x is equivalent to 70 degree, y is equivalent to 25 degree. Now let's proceed with class exercise 1. Without using calculator, find the exact values for this trigo function. So for the first term here, we have to apply sum to product, and this one we have to apply product to sum. So I already give the formula that we have to apply this one. So the next one, we just apply the formula. So I just straight away apply the formula, negative 2 sine 45, and then sine negative 30 degree, and plus half times with the cos 30 degree plus with the cos 45 degree. So again, we have negative angle here. So apply even odd properties. So we found so many times for the sine and also cosine for the negative angle. So you should memorize right now. So we have 2 sine 45 degree and then times with the sine 30 degree. So we can put actually this one, we have negative and we have to put bracket here and then negative. So make sure you put bracket because it is product. Without bracket, then it will become sum and difference. And then plus with the half. So this one already in terms of acute angle. So 45. Then actually negative multiply with negative. So we will get positive. So positive 2 sine 45 times with the sine 30 degree plus half cos 30 degree plus with the cos 45 degree. Then we can substitute with the exact values for the sine 45 degree. So square root of 2 over 2, sine 30 degree, half. And then for the cos 30 degree, square root of 3 over 2. And then for the cos 45 degree, square root of 2 over 2. Then simplify this one. At the end, the final answer is 3 square root of 2 plus square root of 3 over 4. So please be careful when you try to simplify the final answer. So my advice is better for you to apply manual calculation. Don't use your calculator. So for this one, so you may check your final answer. So 3 square root of 2 plus square root of 3 over 4. Now let's move on to the class exercise 2. So this one also simple. We have the between these two angles, cos and cos. So we can apply product to sum formula. So we will get half cos 10 pi over 12 and then plus with the cos 12 pi over 12. Then simplify the angle. So we will get here 5 pi over 6. Then plus with the, so this one will get pi only. Okay, so if you try to check for the cos pi over 6, so this one, it is not acute angle. So we have to find out RA. So that 5 pi over 6 is actually in the second quadrant. So how can we get the RA in the second quadrant in terms of pi? So remember that if the angle given in the question is in terms of radian, so you cannot change. So you cannot change in terms of degree. So you have to remain all the solution in terms of radian. So in order to get reference angle, so pi minus 5 pi over 6, so we will get pi over 6 for the reference angle, and it is in the second quadrant. Therefore, cos 5 pi over 6, the reference angle is equivalent to negative cos pi over 6. So we can substitute in the solution here. So we will get negative cos pi over 6. So always put the negative sign in front of the trigo function. So this one, because it lies in the second quadrant, cos is negative. And then plus with the cos pi, then substitute with the exact values for this special angle. So negative square root of 3 over 2. This one we will get here, cos pi is actually equivalent to negative 1. So minus 1. So the final answer is square root of 3 minus 2 over 4. So this is the final answer for the class exercise 2. Okay, now let's proceed with the example 5. We have here the exact values for the cos A, negative 4 over 5, and given that angle A lies in the third quadrant. So if it is given like this, always start with draw the triangle where the location of the angle given. So since it is in the third quadrant, and put the name of the angle, which is A. So since it is cos, so adjacent over hypotenuse, therefore the opposite is negative 3. So from here actually we can get other trigo function. But in this case, we don't need other trigo function. Okay, so how can we get the exact values? So by using this one, so we can see it is in terms of product. So we can apply product to some formula. So equivalent to half cos, so A minus 2 minus 3A over 2, and then this simplified version is cos negative A, and then minus with the cos 2A. So I already minus and also add between two angle. Okay, we have here negative angle, always apply even odd properties for the cos negative A. So we will get positive cos A. So half, and then cos A, and then this one is cos 2A. So please don't change the angle 2A become A. So what we can do here for the double angle, we have to apply formula double angle for the cos. So we have three formula. So I use the formula that use cos because we already have the exact value for the cos. So this is the formula double angle, one of the formula for the double angle for the cos. Okay, so I can find out outside first the values for the cos 2A. So equivalent to cos 2A equivalent to 2. So cos A negative 4 over 5 squared minus 1. Then you can get the values for the cos 2A. So 2 times 16 over 25 minus 1. So 32 over 25 minus 1. So this one, the answer is 7 over 25. Okay, so how? Substitute the values here. So we have negative 4 over 5 and then minus with cos 2a, we can just substitute the values here. 7 over 25 and then the final answer, you simplify everything, you will get negative 27 over 50. So we will continue next example in the next video.